and welcome to video 3 of section 4, reusing pre-trained models in new applications. In the previous video, we talked about reusing previously trained models as an alternative to training a whole model from scratch. In this video, we will see how to convert raw images to feature matrices, and we will train a Keras model to classify these features. Right now, I bet you are eager to use your new knowledge about pre-trained models. So just go ahead and download the dog versus cats dataset, in case you haven't done that yet. This is the link, and the website to do the download looks like this. Here are the training and test dataset that we will use. Here on my computer, I have already downloaded everything beforehand. After downloading, we will have 25,000 images for training and 12,500 for test. We only have labels for the training set, which is on the name of the file itself. The name format of each file is the following. We have cat or dog, a number, and the JPEG extension. With this video, I'm sending a Python script with the suggestive name, features to hdf5.py. This script loads all the files in a folder, extract the features using scikit-learn Theano, and store the results to a HDF5 file. The default neural network model that it uses is overfit. You can read it carefully later. Here, in our IPython notebook, we can see how to use features to HDF5. The input arguments are the input files path, the output file path, and a callback to calculate the labels. Note that we have to finish the input path with a star, dot, and then the extension. The rule to define your own label callback is shown here. The callback should accept the file name as input and calculate the label of the image from it. For our problem, it is easy. We just verify if there is a word cat in the file name and return 1. Otherwise, we just return 0. It takes a few minutes to load and process all the images in the dataset, so I have done that beforehand. Here are the times that took me to do the whole processing in my computer. Down here, we list our current directory. The script above generated both train.hdf5 and train.hdf5.txt. The latter contains the file names in the order they were stored in the HDF5 file. Finally, we can train our Keras model. First, we import all that we will need here and load the features with h5py, which already comes with Anaconda, the Python distribution that we installed in the beginning of this course. Keras provides a helper class called HDF5 matrix that allows us to handle large datasets into disk. This dataset is not so big to blow the memory of my computer, but we're still gonna use HDF5 matrix for educational reasons. It might be important for you in the future. Here's how we use HDF5 matrix. You can check keras.io for more details and documentation about HDF5 matrix. This is the definition of the model we will train. This is a single hidden layer, fully connected neural network with dropout. Remember that we are using features extracted with overfit. So the overall transformation from the original input images to the labels is actually a 9 layers deep. Just as a recap, dropout is used to add some regularization to the network to avoid it from learning trivial solutions and overfitting to the training dataset. Here are a few details about the parameters for our training procedure. We will train in batches of size 100 for a total of 10 epochs. We will use Keras model checkpoint callback to monitor the accuracy of the trained model in the validation dataset. This callback also saves the best model. The destination file for our best model will be bestmethod.hdf5. This idea of keeping the model state that perform better on a held out dataset is called cross-validation. I bet you already know that, but it doesn't hurt to remember, right? Now let us run our training algorithm. Since I'm using a GPU here, and all the features were calculated beforehand, it is quite fast. It's already done. In this fit method, we pass our HDF5 matrices as input and as validation data. When using HDF5 matrix, Keras requires that we define this parameter shuffle equals to batch, which is a compatible data shuffling strategy. In this cell, we load the neural network that had the best results on the validation dataset. To do that, we simply use the model's load weights method. We can compile a fresh new method with the same configuration and just load the weights. So, if you want to deploy your Keras model into production, that is what we will need to have in your server: the model configuration and the weights, which are stored in HDF5 file. Let us visualize a few results on the test data. Touching the test dataset is something that we should never do in real life, but the competition is already over and we are just studying here. This script just opens the test set features, open the test set files, and pass it as input to the model.predict classes. Keras creates this predict classes function alongside all the other functions when we call the compile method. From the resulting class, we can check which label it represents and plot the results. As a homework, try to investigate the model performance in some other images in the test dataset. Also, try to download some images of cats and dogs from the web, take a picture of your puppy and your kitties, extract features with scikit-learn Theano, and classify them using your freshly trained model to see how does it perform. Also, I have another challenge. Can you think of another problem which you can solve using the same strategy of pre-trained deep convnets plus Keras? If you do something like this, and I'm sure you will do, post it on Twitter or Reddit and tag me. I'd love to see what you can do. In this video, we extracted features from images of cats and dogs using a pre-trained deep convolutional neural network and learned how to classify them using Keras. This video also ends our section. This section was dedicated to learn what is the ImageNet dataset, which models were trained using it, and also how to learn those models with Theano. In the next section, we are going to study my personal favorite subject in neural networks: for loops in Theano and recurrent neural networks.